This is basically giving you a comparison of detailed comparison of the operating data. You can see the pressure drop went down to 14 and 21. We were able to reduce the firing rate to almost like 27. So that was very good actually, good efficiencies. We were still able to generate some steam, firebox temperature and bridge wall temperature and fluxes, everything was in control. So what we told the client that there are a few issues with revamp options 1 and 2. One is the radiant coil is heavier than original because it is larger diameter. It weighs 5 to 8,000 pounds more than the original. We will need new radiant tube supports. Arch will have to be modified. The new convection section will be heavier by 27 to 31,000 pounds. So furnace steel reinforcement modifications are needed to withstand extra weight, and it will have a longer turnaround time and site work. So we gave them these options and we told them these are the limitations of option 1 and 2. And then we gave them the third option. We said, okay, you can revamp your heater just by replacing the convection section. Use our split flow technology. We will divide the feed into 3 parts. 30% will go into the convection section and 70% will continue to flow in the radiant section. And then we will combine them at the radiant outlet. And we were able to reduce a flue gas temperature to almost like 530, so lowest temperature. And this is how the flow control scheme looks like. If you see, all we have is a third pass where we are putting 30% flow. The two passes are being 35% flow. And there is a TIC which is controlling the flow to that convection pass. So, and then the master TIC is controlling the fuel gas flow rate. So very, very simple scheme we propose them. And if you look at it, we are only changing the small convection section what they had and the 4 arch tubes. This heater had also a steam drum. We are not touching the steam piping or steam drum. We are still saving that. So very, very minimal modification. You can see that's what we ended up doing actually. So this was the heater before revamp. And then we replaced the convection section, and we were able to get what they were looking for. We did replace 4 radiant tubes in the top at the arch and made it a part of the third pass because we wanted to balance the heat and the pressure drop. So we did do that. But basically, just by doing this small modification, we were able to give them all the 3 parameters. So if you look at it, we were able to get process duty up to 37. We were able to optimize the pressure drop all the way to 20 psi. Allowable was 25. You see the mass fluid velocities are pretty good. We were able to keep the firing rate down to 49. Actually 55 was the limit, and we were still able to get them the waste heat recovery, and the overall efficiency was 85%. So in our mind, basically it was the best option to go for. And you can see these are the 3 radiant section modifications. In the first 2 modifications, we are changing the tubes. And in the last modification, we are not touching the radiant section except the top 4 tubes. So a lot of modification was needed with option 1 and 2. And these are the cost estimates of option 1 and option 2. And you can see both the options 1 and 2 were costing about $2.3 million. The option 3 was $1 million. Now you will also see we would have made more money if you would have sold them option 1 and 2, And in option 3, we've only made half the money. Our fee was almost half of what we would have charged them for option 1 and 2. But we did the job for less than $1 million. And the client gave us and we executed it. So lower cost, that was the advantage. You can see the convection section in this picture. Lower shutdown time, no structural modifications required, no civil works foundation required, and better performance. So this is a picture of split flow convection section for that project when it was being fabricated. It's, as you can see, it looks like a very small convection section. That is with the end tube sheets. This is with tubes which have been put in there. So our cost was less than half of the conventional revamp cost. So we try to provide you with unique solutions as part of your team and give you the best available for your heater. Here are the revamp jobs, which are split flow references we have done. The first one which I showed you was for Citgo Corpus Christi #4 platformer heater. We saved our client 50%. The second was for Valero in Texas City, where we put this platformer split flow in not only platformer, but in naphtha hydrotreater units. Then we did this reactor charge heater of the case study, which we told you. And the client liked our split flow so much that we ended up putting in 3 more heaters, one in the hydrogen heater and 2 in the reboiler heaters. Similarly, Valero gave us another project in Wilmington to put this split flow project. Phillips 66, we did a job for Wood River Refinery where we installed the split flow. And in HPCL Mumbai, we installed it in 6 heaters, extract and raffinate heaters. And it's been working very, very nicely from there. So in summary, what I would say is we are giving you capacity improvement and optimizing the pressure drop. An additional pass in convection section can increase the capacity by 20 to 25%. No need to modify the radiant section. It is low cost revamp as compared to the conventional revamp. It can save you $1 million. It has been proven, and working well for so many clients. Let us know if we can install it in your fired heater. Contact us at info@heatflux.com, and we will try to give you the best possible technology. So thank you very much. And I look forward to answering your questions now. Please give me a minute to see the questions panel over here. Hey, Ambreen, can you help me here? How do I see the questions now? Yeah, that's okay. Yeah. Yeah. So I want to see how can I. So the first question I got is, I don't know how to. I'm still at new webinar, so give me a minute to fix it. Okay, so with the reduced flue gas temperature, is it recommended to combine this technology to a furnace with an existing pH? I don't see any problem. This is irrespective whether you have an air preheater or you don't have an air preheater. It will be, it can be installed actually. I don't see any issue. Any other questions which we have? If anybody has any other questions, please let me know and I will try to answer them. We still have a few minutes left, 5 minutes available. So the next question we have is, wouldn't the additional tubes in the convection section affect the draft of the furnace? Is the furnace stack damper enough to maintain the draft with this technology? Absolutely. So we do a complete re-rating of the furnace and we want to make sure that any additional surface we add, you still maintain the draft, enough draft in your heater. So the heater is completely re-rated. It's not just the convection section. We re-rate and make sure the stack, the burners, everything is working. So good question, because convection section, we can always increase the width. Okay, I got it now. What kind of revamp we have to do if you want to use furnace with design duty of 11 megawatt at a reduced the duty to reduce with 30%? Uh, I think you have to re-rate the heater at a lower duty and make sure that the burners can be correctly sized. Also, the stack and the minimum tube metal temperature so that there is no dew point corrosion in the heater. So what is the revamp duration downtime of the unit? Typically, since we limit our modifications to the convection section, and convection sections can be fully shop fabricated, so the time for most of these projects has been like 2 to 3 weeks, depending on what other modifications which we are doing. What are the methods to control tube skin temperatures? Only by adjusting the firing in the burner or any other method uh, when the burners have adequate capacity. So this webinar which we are doing today is mostly for uh, split flow capacity today, but we will definitely have another webinar where we will discuss the burners. The main thing is you have to make sure you don't get any flame impingement. And that's what we will focus on our next webinar, how to make sure you don't have any flame impingement and you can lower your tube metal temperatures. The split flow technology appears to be very simple. Why wasn't it considered in the past? Is the control of the split flow critical? What about the draft limitation? So good question, Craig. I think there are so many things we don't know why it was not considered. I think maybe historically it was not needed actually. And the split control of the split flow is not critical. We did our first project by just using orifice plates. It is not something which we have to do it, but there are some clients uh, uh, who want to have the exact temperature. But if you're not worried about exact temperature, we could just put simple orifice plates and divide the flow actually 30 and 70, so that it can be done that way. The new heater had platforms on the stack. Was that for SAM's? Nice. Yes. SG stands for steam generation. So how does the split flow technology affect the draft? No, it does not affect the heater draft. I think we make sure that your heater has sufficient draft even before, as before. So your firing rate, you are not draft limited after split flow, and you have plenty of air and plenty of uh, fuel you can fire still. Have you done split flow with vertical can heaters? Yes, we have done split flow with vertical can heaters. We did uh, two projects, the two heater for Philips 66 reformers were vertical can heaters. The two heaters in fact, three heaters for Delec were vertical can heaters. Yeah, it can be done. Has this been evaluated on delayed cooker heaters? If so, how do you handle the skin temperature on the turn down? So we have not looked at delayed cokers. Delayed cokers, as you know, are the critical heaters, and it can be done, but we have not looked at it. I think there are other ways. Do you have a reference in Europe? No, our references are mostly in US. Can you apply this technology to crude atmospheric furnaces? Yes, we are working with two of our clients uh, on applying this technology to crude heaters. We have done the engineering study. We have also done the PDB study. So we are just waiting for the execution. And there, what we are trying to do is to reduce the pressure drop. And the split flow basically offers us a way to shift heat from the radiant to the convection. So one of the things we are doing there is trying to lower the heat flux. Can CO emissions occur if the radiant section is too large? Normally, CO emissions do not occur if the radiant section is too large. CO emissions occur if you go down, if you have bad combustion, or if your flame temperature or firebox temperature goes down very, very low. Thank you all. We will try to send you the answers. I think so. There was your examples are for retrofits. Would split flow technology be advantageous for new fabrications? Why not? I think it can be done even for new heaters. I would say for platformer heaters, you can always go and reduce the size of the platformer. You can reduce the size of you can reduce the firing rates. And if you don't need steam, you can have a value heating actually. You had platforms on all three stacks? Yes. No, so the draft, I mean, we just want to let you know that we make sure that the complete heater is rated and the draft is never an issue actually.